Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from University of Delhi. So presently we are going through the fundamentals of programming in C++ in the form of a lecture series, and the current topic which we are dealing with is functions. So today's agenda for the lecture is inline functions and function overloading. So we will be learning the concept of inline functions first, and then we will see what actually function overloading is. So with this platform set, let me begin with inline functions. So whenever I am saying a function, you all are aware what do you mean by a function and how a function call executes, in the sense whenever there is a call for a particular function inside the main or inside any calling function, what will happen? The the control jumps to the definition of the function wherever it is written, and then after executing those steps of functions or those I can say instructions of functions, the control and return value, if it is there, will come back to the just onto the next statement from where the control has been transferred. So every time there is a control switch from calling function to the called function, and then back from called function to the calling function. So if I can say, let's say my function itself is maybe a one liner or maximum maybe a two liner, switching this switching this execution from calling to called and then back is actually a kind of expensive operation, or it's a kind of complex operation for the compiler. So inline function came here as a solution. So in case of inline functions, if my function is declared as an inline function, so inline here is a keyword. So if a function is declared as inline, the compiler inserts the code of an inline function at the address where the function is called. So now it is avoiding that jumping from calling to called and then back. So it is just ignoring that jumping, avoiding that jumping to the subroutine, and it is just taking the code of the function and it is inserting at the place or at the address, I can say, where the function is called, provided you have declared that particular function as an inline function. Now how are we going to declare a function as an inline function? So the idea is very simple. We just need to use the keyword inline in the function header. For example, if you can see on the screen, I am having one function max with two integer parameters x and y, and one integer as in return value. As the name indicates, this is going to give you the maximum of these two integers. Now I can declare, because see how long is the code of this function max? It is just a single liner code. So I can declare it as an inline function. So I will say inline integer max and then their parameter list, and the within the curly bracket that one or two liner body. So I will be returning x greater than y, conditional operator x else y. So if x is greater than equals to y, x will be returned, else y will be returned. That's as simple as that. So we have even in place of an if else, we have used one conditional operator. So now my code is actually a single liner code. So whenever I am going to call this function max, wherever I am going to call this function, so compiler will actually avoid the overhead of jumping from called function from calling function to the called function. It will instead replace this code, or it will insert the code wherever this function max is called. So program code will expand each time an inline function is called. So that's why I am insisting that inline functions should not contain more than one or two instructions. So even if you tried to make an function inline and that function is having many instructions, then in that situation the compiler may ignore the inline word and issue a warning. So, even if an inline function contains a lot of instructions, compiler may ignore, depends. The compiler may ignore the inline keyword. Compiler will try to treat that function as a normal function, and then for that a warning will be definitely issued. So, a inline function, I can say, must be defined in a source file in which it is called. We cannot simply supply the prototype of the function. That means the definition of the function must be there, in which in the source file in which the function is called. Just mentioning the prototype in the file in which it is called won't help for inline functions, because that body of the inline function has to be replaced wherever it has been called. So, the idea behind this is the code containing the instructions must also be readily available to the compiler, and it therefore makes sense to define inline function in the header files. I can say you can define as in contrast to normal functions. So, this means that the function will be available in several source files. That is one idea you can kind of experiment with your inline functions. Now, inline functions, if you can see, are quite similar to the term, or quite similar to macros. So, inline function, or we can say, are alternative to macros with parameter. Whenever a macro is called, the preprocessor simply replaces a block of text. In contrast, whenever an inline function behaves like a normal function, although the program flow is not interrupted by the function branching. So, yes, I can say inline function serves as an alternative to macros with parameters. Now, with this concept of inline functions, now I am coming to the second part of the lecture, which is function overloading. Now, before coming to the concept of overloading, let me mention here, as we are going through the series of Introduction to Programming in C++. So, the basic, or the there are many, but the bottom line difference between C and C++ is your C++ is an object oriented programming language, while your C is a normal function based language. And in object oriented programming paradigm, we have many kind of facilities which are available in the programming system, and one of those facilities, or one of those characteristics of object oriented programming languages is polymorphism. Yes, polymorphism, and polymorphism can be achieved with the help of overloading, and here we are going to study function overloading. Now, let us see what is actually happening. Whenever I am defining a function, and let us say my program is complex enough and I need to define let us say 4 or 5 functions or n number of functions, and I can have 2 or more function with the same name but different parameters. So, 2 or more functions can have the same name but different parameters. This phenomenon is called function overloading, and the function which is having different argument or parameter list but the same name, that function is known as overloaded function. So, now the function overloading, why a function overloading concept is required? Because that is a feature which is used to improve the readability of the code. Readability of the code in the sense, so by using same name for different functions which are we can say they must be logically related. How? I am coming to this in a short while. So, function overloading is used so that programmer does not have to remember many functions name if they are, I can say, logically connected somehow. Now, see what is happening. So, function overloading is actually a way of having compile time polymorphism. There is also one concept which is runtime polymorphism, but compile time polymorphism can be achieved with the help of function overloading. Now you can see I am having two different functions which are having the same name, that is sum. One is having two parameters, integer a and integer b, and another is having three parameters, integer a, integer b and integer c. So one can have the following functions in the same scope. So the name of the function is same, which is sum. One parameter list here of one function is having two integers, integer a and integer b. Another parameter list is having integer a, integer b and integer c. So the previous one is having two parameters, the next one is having three parameters, but the name of the function is same here. Now how is a compiler is going to resolve this function call when there are many functions with the same name? So the key idea here is the parameters must fulfill one of the following conditions. Now what are the conditions? There are three conditions. Either the parameters have different type, let us say one is integer, two integers in one function call, two float in another function call, so different type. Either they have different numbers, for example we can say different number is the example given here. Here I have taken two integers for one call and three integers for another call. So different, I can say number of the parameters, that is also okay. Then the third condition is they should have a different sequence of parameters if they have different types. For example, one function could be calling integer and then float, another function could be calling float and then integer. So on the basis of parameters, the compiler is going to resolve that which function is being called, because the name here is the same for all functions. Now for example, I am having a function, let us say max, in which two integers have been passed and it is also returning an integer, either a, if a is greater than b, or else it is returning b. So another overloaded form of this function is in which two float variables a and b has been passed, and then it is also returning a float variable. Now here the code is same, that it is going to return a if a is greater than b, or another situation it is going to return b if the first situation is not satisfied. But the parameter list here is different. The earlier parameter list was having two integers and also the return value is integer. Here the next parameter list is having two float variables and also the float value as the return value one. Now depending upon, let us say for example I am calling integer a is equals to max integer x comma integer y. So my compiler will understand that I am calling the function which is written at the first place, or I can say for example float c is equals to max float a and float b. So in this situation obviously I am referring to the second function. So depending upon the parameter list in the call, compiler is going to resolve the conflict. Now my point is, we have seen why what actually this function overloading is. Now the question which automatically arises is, what is the need of function overloading? Why do we need to have functions overloaded? So function overloading, as I have told you, one idea behind function loading is the code reusability. Code reusability in the sense the programmer is free from having the functions max1 and max2, where max1 refers for integer, max2 for float. So, I mean not so many naming conventions or not so many names are required by programmer. Another idea or another kind of advantage of function overloading is function overloading is actually compile time polymorphism. We can say it is similar to runtime polymorphism, and it is helping us to get the different behavior of functions or of modules with the same name of functions. So, that is why what the idea behind is, one is code reusability, so that your what you call this thing, programmer is not kind of need to have many names for similar kind of functions. So, that is what I was insisting upon, that functions should be logically connected. For example, I have taken two functions which with the same name, let us say sum or max. So, how these are logically connected? So, one is the max function which is taking max of two integers, another is the max function which is taking maximum of two float numbers, but the idea is same, is to take a maximum from the parameters. So, I can say yes, they are logically connected, or I can say let us take the example of sum function. So, in case of sum, I was having two parameters at one time, and for the next call I was having three parameters. So, if I am saying sum 10, 20, 30, so the second call will happen if I am saying sum 10, 20. So, the first call will happen, but both the functions, the agenda is to find sum of whatever parameters are being given. So, here I can again say they are logically connected. Now, let us try to explore or understand, imagine a situation in which I have taken the function name as sum, and for two parameters it is taking the sum for two integer parameters, and when float is being passed, it is taking by code, it is taking the maximum of the variable. So, this is a kind of situation which is not prohibited by the compiler. Compiler is not going to say anything, or compiler is not going to issue any warning, because either it is sum or max, it is, these are just variable names, or these are just function names for the programmer. But having two functions with the same name sum, one which is calculating the sum and another one is calculating the max, is not actually a kind of, you can say, a clean idea for programming. This is going to make your programmer, or this is going to make your user kind of more uncomfortable, and here you are going to lose the idea of code kind of reusability or code readability, I can say. So, that is why I was insisting upon that functions in which you are having the same name with different parameter list must be logically connected. Now, coming to what are the rules of this function overloading. So, in order to resolve the call, the compiler is going to look at the parameters. So, for parameters we have three different conditions. One condition, or the first condition, says these functions must have different parameter types. So, the one condition could be the parameter type should be different. For example, as given on the screen, you can see sum integer a integer b, and the second call says sum double a and double b. So, what is the difference between these two calls? It is only just the kind of, we can say, parameter type. There are two parameters of the same type, but if we consider different calls, one call is having integer parameters, another call is having double parameters. Another idea on which on basis of which your compiler can resolve the function call is number of parameters. So, number of parameters, For example, one function says sum integer a comma integer b, and the second call says sum integer a, integer b and integer c. So the previous call is having two parameters in the list, and the next call is having 3 parameters in the list. So depending upon what kind of call you are going to place, that means within that call how many numbers of integers you are going to place, the compiler will be able to chalk out that whether the previous function is being referred or the later function is being referred. The third idea is, even if they have same parameters, that means as the example shown on the screen, the function have both the functions which is named as sum are having 2 parameters, one is integer, another one is double. So the first call says integer a and then double b, that means the first parameter in the first call is a and the second parameter is double variable. In the next call I am passing double a integer b. So that means here now the number of parameters is same, I can say type of parameters is also same. What is happening? One parameter is integer, another parameter is double for both the calls, but what is different here is sequence of parameters. In the first call integer and then a double is being passed, in the next call first a double and then an integer is being passed. So the functions, if they are having same number of parameters and same types, they must have a different sequence of parameters, otherwise your compiler will issues warnings and errors to you. Now coming to one more example of whether it is going to create any difference, yes or no. We can have any number of functions with different parameter list, but parameter list has to be different, as we have seen, either in the type or the number or the sequence of the parameters must be different. So now one situation arises as given on the screen. I am having 2 calls. One is having 2 integers, another one is also having 2 integers, and the function is being overloaded. The name of the function is mul. This is for multiplication, as the name indicates. What is the difference here? The difference here lies in the return value. The previous call or the first call to function mul is returning integer, and the next call to the function mul is returning a double. So now the question arises whether compiler will be able to resolve this type of conflict. The answer is no. Parameter list is same, this is not allowed. So at least the difference of either the type or the number or the sequence in the parameter list must be there. You cannot have same number of parameters, same type of parameter, same sequence of parameter in the parameter list, and then you start looking for the difference only on the basis of return value. This is not allowed. Only on the basis of return value your compiler will not be able to resolve the calls. So even though their return types are different in this situation, one is having integer, another one is having double, it is not a valid call. Your compiler is going to issue a warning here. Now coming to how this function overloading actually works. So whenever there is a function call, your compiler will start looking for the definition of the function and it will look for an exact match. Exact match in the sense it will look for the exact function name and the exact parameter list. So for example, integer and double is the parameter list. So if it is going to find an integer and double with this with the function name which it is looking for, I mean it's a win-win situation for the compiler. If not an exact match is found, if there is no exact match is found, then what will happen? Then the we can say automatic promotions help, like your character, unsigned character and short, these can be promoted to int, or we can say float can be promoted to double. So kind of we can say automatic typecasting from one data type to another, obviously within the possible limits, will happen, and now your compiler will start looking for the match. So even now with all these situations, there is, let's assume that there is no exact match, and with automatic type casting, your compiler is still not able to find an exact match. So even if no match is found, your compiler tries to find a match through standard conversion, as I have explained. So even if it is not available, then in that situation your compiler will raise an error flag and will and say that prototype is not matching. So that's how your function overloading works. Let me summarize the lecture. In this particular lecture, what we have seen earlier, we have started with inline function and see what are the inline function and what are the advantages of inline function. Then we have gone through function overloading, why function overloading is required, what are the rules of the function loading along with the basics of function loading, and towards the end I have explained that how this function overloading works, especially in C++. So here is a list of references which are being used for preparation of this lecture. Hope you have enjoyed the lecture. Thank you for a patient hearing.